Hello guys, welcome to this evening's lesson. So in this lesson we'll be treating types of motion, and specifically we'll be zooming into translational, random, oscillatory and rotational motion. So let's see what we have. So there are different types of motions in physics, and as I said at the beginning, I said there is translational motion, random motion, oscillatory motion and rotational motion. So each of these types of motion, they have their distinct characteristics, and they are being studied individually in physics cases or in different, even science generally. So let's see. Translational motion. So translational motion refers to a motion that of where an object is moving in a straight line or along a curved path without going back to its starting point. So it's as with what I have here, I said it refers to the motion of an object in a straight line or along a curved path where every point on the object's movement every point on the object moves the same distance in a given time interval. So for translational motion now, we would have a particular object moving from one point to another point, or that particular object moving from one point to another point in a curved path. So long as it is not moving forward and coming back, it's called translational motion. In a single direction, it's called translational motion. So when we go to the next one, we'll see why I'm emphasizing on this. So next we have random motion. So random motion is a kind of haphazard motion. It does not have a specific direction. It's usually just scattered. You see the particles or the motion is going to be without a direction, just going recklessly. So this kind of motion is called Brownian motion, when they don't have a specific direction. So this particular type of motion is called random motion, and it is an irregular motion where objects or particles are influenced by random forces such as collision or external disturbances. So next we have is oscillatory motion. So when we talk about oscillatory motion, we're talking about motions that are moving to and fro. Oscillatory, either to and fro or up and down. So once it's moving in a rhythmic pattern, in a rhythmic repeating pattern, we have an oscillatory motion, like the pendulum bob we know. When we see a simple pendulum bob, where we something like we tie a bulb with a thread and to dangle across the room in a particular direction. Once it gets to a particular extent, it then stops there and comes back again to its initial point here and comes back again. You see continuous movement, left, right, left, right, left, right. So these kinds of movements where you're moving left, right, up or down, they are known as oscillatory motions. So they are the types of motion that are seen in systems like swinging pendulum or vibrating string. Vibrating string are always vibrating either up and down or side by side. So this kind of motion is characterized by parameters such as amplitude, frequency, and period. So let's see what rotational motions are. Rotational motion is motion that moves around a fixed point. So before you say something is rotating, it means that you can be able to draw a line, and that particular thing is moving across that line, moving in a circular path around that line. I think around is the better word. So when you have any object moving around a particular axis continuously moving around a particular object or a particular orbit continuously, that kind of motion is known as rotational motion. So in the case where you stand and someone will be running around, the person is exhibiting what is known as rotational motion, because you are a static point and the person is moving around you, that static point. So that kind of stuff is what is known as rotational motion. So now let's further move on to what we have. The relationship between these different types of motion. So for translational motion, the center of the rolling wheel moves along a straight line, and this represents the translational motion of objects as they cover different distances. So these different types of motions, they have their differences. For translational motion, it's a kind of motion that does not go back and forth. It could be going in a curved path, it could go in a straight path, similar to oscillatory motion. But the difference between translational motion and oscillatory motion is that oscillatory motion, they move back and forth repeatedly, while transitional motion just does that particular task a single time. Those are the difference between oscillatory and transitional motion. So for transitional motion and for oscillatory motion and um, rotational motion, for oscillatory it needs to just be moving left and right, or to and fro, or up and down. But for circulatory, it means to be moving around a particular cycle or a particular fixed point. So that's the difference between these three types of motion. So now let's see the significance of each of these type of motion. So it's very important that we know that transitional motion is fundamental in kinematics. Transitional motion is fundamental in kinematics, while random motion is crucial in statistical mechanics. Oscillatory motion is important in wave phenomena. Oscillatory motion is for wave phenomena, and rotational motion is for important stuffs in cases of machines and machineries. So when you talk even in satellite movements, rotational motion is also involved in that kind of scenario. So in conclusion, we have that we've treated the different types of motion, and I've tried explaining them and also talk about their distinguishing factors. Also talked about the benefits of each of these types of motion. So that will be all for this lesson. I'll be saying goodbye.